Okay, so now I would like to hear from you guys a different number that would be analogous to writing 1/3 in binary, or I shouldn't say a different number, a different idea, something different. Not writing 1/3 in binary, but something that would be that you think probably would be similar to writing 1/3 in binary.
Well, maybe like writing 1/6 in base 5 or something like that.
Okay, that's an interesting idea. Let's see if we can write 1/6 in base 5. Okay.
All right.
So base 5, we're going to have the digits be the 1/5,
The 1/25.
the 1/25, the 1 over 125,
625.
etc. Okay, 1/6 in base 5.
Well, I think the same scenario might happen here.
Okay.
Because 1/5 is bigger than the 6th.
Alright, so we start off with a 0.
So the 1/25th will work.
Well, yeah. Well, you could use, but you need to use more than one of them.
Okay.
So,
How many?
well, you can use 4.
Ah, we can use 4 of them. Okay.
It's 4/25.
So I'm trying to write 1/6, but I have 4,
25th.
I'm going to subtract away 4/25ths. Okay, what is 1/6 as a fraction that's really close to 4/25ths?
It's 4/24ths.
Yeah, it's 4/24ths, so, 4/25ths is a little smaller, but
Right.
just barely. Alright, how does this simplify?
Well, common denominator, well,
I think it'll be
Common
one.
denominator.
It's gonna be 1 over 150. I think.
Okay, yeah, so this equals 1 over 150. And remember how I could always take a 4 out of the base, the thing in base 2?
yes.
The analogy here is I can take a 25 out of this. I can say this is 1/25 times 1/6. Okay, that might be an important thing to remember.
Okay.
All right.
Alright? But anyway, I'm left with 1 over 150. So what should I do now?
Well, 1 over 125 is too big,
Okay, so I'm going to do the 0 there.
and then but 1 over 625 works, and again we'll probably do 4 of them.
Alright, so I'm trying to write 1 over 150. Minus 4 over 625. Now here, what can I take out of the 150 and the
You
625?
can take out the, you can take out a 25.
Okay, so I get 1/25 times 1/6 minus 4 over
4 over 25.
25.
So that's what we found before.
So this is what we found before.
So it'll run in a loop again.
Yeah.
0, 4, 0, 4.
0, 4, 0, 4, 0, 4, 0, 4. Now, so this is 1/6 in base 5. Okay. All right, but we think anyway. How can we tell if this is does this really equal 1/6?
Well, we can multiply it by 5.
Yeah, if we multiply it by 5, everything shifts over. And then we
Right,
add
because
1.
5 in base 5 is 10 in base 5.
So that'll shift everything over.
So if this is x, then 5x is
4, 0.
0 point.
0, 4, 0. And then if you add these two together, that's 6x.
6x equals,
4, 4, 4, 4, 4. And this, so in this case, that equals 1.
so x equals, this is 1,
So x equals 1/6.
x equals 1/6.
Cool.
Good analogy. All right, so what are some other ones? Like, what do you think, how do you think, based on this, what do you think 1/11th is in base 10? Can you tell me? 1 over 11 in base 10. So we found 1/3 in base 2,
That was 0.
0.0101010101.
So this could
1/6 in base 5 was 0.04040404.
this might be 0.090909.
Why do you think that?
Well, if you multiply by 10, you shift over to 909090 and then you add it. And that's 11x, so and that equals 0.999 repeating
Uh-huh.
to 1. So if you divide by 11, it's 1/11.
All right, good job. High five. Okay, one more.